Okay, could somebody confirm you can hear me?
Yes.
Yes, we can.
Okay, great. Let me share my screen. Don't think I need this anymore, but let me leave that just for a moment. And let me go get the labs. All right, so today is January 12th, and we're going to be covering Lab 3, Microscope Basics. Please recall that you do need to pick an infectious disease and then email me to get it approved before you can work on the project. You must clear it with me because I do not allow two students to work on the same topic, although you can work on different topics. Like somebody requested to do the flu, and I requested them to tell me, do you want to do influenza A, influenza B, or influenza C? And I think somebody asked for hepatitis too, and hopefully they got back to me. And there's several hepatitis, and these are more different than the flu, and that is they're different diseases. There's hepatitis A, hepatitis B, hepatitis C, and I believe there's hepatitis D and E, but don't do hepatitis E because I think it's a viral parasite of hepatitis D virus, but I don't remember. I'd have to look that up. But certainly hepatitis A through D may be done. All right, so if there aren't any questions, let's talk about Lab 3, Microscope Basics. Any questions?
Yes, I had one actually
Okay.
for the results for the P1 and then the P2, because the background kind of on one side looks lighter than the other. And I'm just kind of confused. One of them looks like result for one looks kind of turbid, but then the other one, you can see like a dark background and it looks kind of cleared, but it just looks different because of the shading on the background.
If there's growth in the tube, the media will be turbid and the bacteria will usually have a little bit of a color. It might be off-white though. And so that would look lighter usually than the media without any growth in it. Is that what your question is?
Yeah, basically.
Okay. Well, then I think I answered it. All right. Lab 3, Module 3, Microscope Basics. If you have any other questions, just ask me directly what the question is, and I will help you after I've done my talk on the lab. It looks like the spacing has gotten off on this page, but read the lab module in the class textbook. You need to read chapter 3 through the end of the section on compound light microscopy. There will be some video clips and some online exercises for this lab. You're not physically going to be using a microscope. Oops, the lecture just finished. That was rather rapid. You're not going to be doing the lab module, but you should be able to do some things on the online virtual exercise using a microscope virtually online, meaning on your web page. So you should be able to locate and name the parts of the compound light microscope along with describing the functions of those parts. You should be able to calculate the total magnification for an object that you're viewing under each objective that you're using. And there are 4 objectives you need to know about. And we'll talk a little bit about how you do that. Know the guidelines for focusing a specimen with the different objectives. You should always start with a scanning lens, then move up to the low power lens, then move up to the high power lens, and finally move to the oil immersion lens. Now, generally, I don't call them that. I call it the 4X lens, the 10X lens, the 40X lens, and the 100X lens, because students get confused. The low power magnification lens is not the lowest. The high power magnification lens is not the highest. You got that? So I just use 4X, 10X, 40X, and 100X, and it's less confusing. But they do have other names, which I just used there. Estimate the size of a specimen when it's seen at the different magnification powers, meaning a different magnification lens, and we'll talk a little bit about that. Understand the rules for using a proper microscope and the care of using the microscope. You're not actually going to be using a microscope, but you do need to know how to use it and take care of a microscope. And then lastly, define the terms associated with the microscope. So memorize the names and the functions of these parts of the light microscope. One, that's the eyepiece, also called the ocular lens. Two is the objective lens. Right there, we're looking at the 4X lens, or the lowest power lens, which is called the scanning lens. And it rotates right there. You don't need to know this piece, but this piece can rotate around, and that we call the rotating nose piece. And that's how you move the different objective lens into focus or into the view of the specimen. This part right here is the stage, and that's allows you to move up the specimen or down the specimen, as well as back and forth. And then I guess whatever that way would be, back and forth, forward and backwards, I guess, I don't know. And that's the stage clip number 4, holding a slide on the stage. Where's 5? I don't know, there it is. 5 is the lever for moving the stage clip. 6 is the iris diaphragm, which is a lever for opening and closing the diaphragm. The diaphragm is sort of like the shutter in a camera, and you can open it or you can close it. The wider it is, the more light that comes in, and the more it's shut, you can shut it down to a pinprick, the less light comes in. Right next to the iris diaphragm is the condenser, and it just focuses the light from the lamp, which is right there, onto the specimen. Not focus, yeah, arranges it and focus it. It doesn't magnify. The iris diaphragm doesn't magnify either. It just changes the amount of light that can come in, and you can say a cone of light is coming in, and you can have a bigger cone or a smaller cone. 8, that's the coarse focus adjustment knob, and it can lower and raise the stage, and you use that to bring the focus of the specimen into coarse focus. So the coarse focus adjustment knob. Once you get close to in focus, you then use the little knob over here, number 9, and that's the fine focusing knob. 10, that's the light switch. You turn it on and off. 11, I call it the rheostat. It can increase or decrease the light once you turn it on. I think in this lab manual, they don't call it a rheostat. I think they call it the light intensity dial. Same thing, a rheostat. All right, any questions about these parts? So these are the parts you need to know. The ocular lens and the objective lenses magnify the specimen that you're viewing. In our lab, all of the ocular lenses can only magnify 10 times. And most compound microscopes, have a 10x ocular lens. A compound microscope is one that magnifies twice. The ocular lenses magnify 10 times, and then the objective lens magnifies as well. So that's a compound microscope. A simple microscope only has one lens that magnifies. The objective lenses, and there are 4 in our microscopes, also magnify the specimen. We have 4 different lenses for the objective lenses. There's the 4x lens, and it can magnify 4 times. The 10x lens, it magnifies 10 times. The 40x lens magnifies 40 times. And then the oil immersion lens magnifies 100 times. Any question about that? See if I need to say anything further about these. Nope, I think I discussed all of those. All right, so you need to know this table in the lab. If you were actually coming into the lab, you would know that table you have to memorize anyways. It's the next table you would actually be doing, but we give you the answers because we're taking the class online. So this table you need to know. You should know the power of the lens, and you can name them that, or you can give them their other names. And then the total magnification. For our microscopes, the total magnification is simply 10 times the power of the objective lens. You got that? Because the ocular magnifies 10 times what the objective lens is magnifying. I guess I should state that you can have another ocular lens. We don't have any in the lab, but you can have an ocular lens which magnifies 20 times. And those would be the best and the most expensive microscopes, which in our microbiology lab, we don't have any of those. Any questions? All right, so the 4x objective lens has the greatest depth of field. Depth of field is when you're looking at an object, how much of the depth can you see or view in focus of the specimen. And the 4x lens has the greatest depth of field. The 10x lens has less depth of field, we'll say about half. I need a piece of paper here. Close enough. The 40x lens has even smaller depth of field. And then the oil immersion lens, the 100x lens, has a very narrow depth of field. And essentially all you're focusing in and able to see is one plane of the object. Any question about any of that? All right. Next, we have the field of view, and that is how much of the slide you can see under the microscope. With the 4x objective, you have the largest field of view. So when you're looking at the specimen or the slide under the scope, you'll see a round field. And usually it'll be something like that with the 4x lens. Okay. When you go up in power, you'll get a smaller field of view. So the 10x lens would have, instead of this field of view, it would have something like this field of view. The 40x lens will have even a smaller field of view. And then the 100x lens will have a very tiny field of view. So in comments, the 4x lens is the easiest to use. You can see the specimen in focus for the greatest amount of depth, and you can find the specimen for the largest field of view. And then the 100x lens is the hardest to use. It has the smallest depth of field and the smallest field of view. Any question about that? All right, it's also noteworthy that when you're viewing an object under the microscope, it is magnified, but it is also inverted and reversed. So the letter E, if you were to look at it under the microscope, it wouldn't look like that. That's what it looks like to our eyes. It would look like this under the microscope. It is magnified, but it is inverted and reversed. Any question about any of that? All right, let's talk a little bit more about the iris diaphragm. It can be opened or closed to allow more or less light to get in. However, the most important part about the iris diaphragm is what the setting you have can affect the contrast of the specimen against its background. So when you're viewing a specimen against the slide, which will be cleared, and I got a black specimen, so it has high contrast to the slide, which is clear because it's glass. It's easy to view, but the specimens we look at, microorganisms, are made of water, and so they're going to be very close to the contrast as the background, the glass of the slide. And so you want the best contrast you can get. And one way of increasing the contrast is to set the iris diaphragm at the optimal level to give high contrast. The iris diaphragm is also described by this lab as your most important tool in adjusting the light. You can have the cone of light coming in very large, or with the iris diaphragm shut almost all the way. All you have is a little pinprick giving you a cone of light and a pinprick. Now, with that stated, when you're adjusting the iris diaphragm, and you're not going to work with an actual microscope, so I'll just tell you that generally you want the cone of light coming up being equal to the field of view for your objective lens. So for the 4x objective lens, you want the iris diaphragm to be fairly open to give a large field of view, and actually the same field of view as the objective lens. And let's go down to this one here, this table here. For the 4x lens, the diameter of your field of view is 4.5 millimeters. So you want to have the iris diaphragm open to about 4.5 millimeters. Now for the 10x lens, the diameter of your field of view decreases to 1.8 millimeters. So you want to shut the iris diaphragm down to 1.8 millimeters. And that will give you better contrast than if you were to leave the iris diaphragm to 4.5 millimeters. With the 40x lens, the field of view then decreases to 0.45 millimeters. Once again, you want to shut the cone of light coming down to about 0.45 millimeters. And then the 100x lens has the smallest diameter of the field of view. It's only 0.18 millimeters. And so what you want to do is shut that iris diaphragm down to smaller than that. You want it shut down to a pinprick, okay? And then you'll get the best contrast. And if you need more light when you're using the 100x lens, because you've shut down the iris diaphragm to 0.18 millimeters, then you up the rheostat to increase the amount of light coming through. Any questions about any of that? All right. Some tips for focusing. When you first use the microscope, you should use the 4x lens. Use that, put it in place, because it's the easiest lens to use. You'll have the easiest time finding the specimen and then focusing in on the specimen. Use the coarse focus adjustment knob at first, slowly to raise the stage to bring the object into coarse focus. Then switch to using the fine focus and bring the object into perfect focus. Now, from now on, do not use the coarse focus knob. And you should never use the coarse focus knob with any objective lens except for the 4x objective lens. All additional focusing will be done with the fine focus knob from now on. Now, before you go up to the next higher power objective lens, take the specimen and move it into your center of your field of view. The reason being, let me see if I can get something here. Let's say you're looking, this is your field of view. It's not very round, but you can see it's the field of view. If your specimen isn't here and it's someplace over here under the 4x objective lens, when you move up to the 10x objective lens, the field of view will be smaller. And so this specimen will no longer be in the field of view. That's why you move your image to the center of your field of view and then move up to the next objective lens. That way the specimen will be in the new lens, which has a smaller field of view. Any questions about that? All of the lenses are on our microscopes are parafocal, which means that when you switch from one objective lens to another, they'll all be in focus or nearly in focus. So you should just use the fine focus knob to bring the specimen into fine focus. Any questions about any of that? All right, you repeat the steps that I just mentioned, steps 9, from one objective to the next, meaning when you go from the 10x objective to the 40x objective, once again, you move the object into your field of view, center of your field of view, and then you switch the objective lens into the next higher objective lens, and then you fine focus if you need to, and then you move the object into the center of your field of view before you go up into the 100x objective lens. Any question about that? All right, the objective lens, 100x objective lens is special, and it really does not give you any better magnification unless you use oil. That's why it's called the oil immersion lens. For it to work, you have to use oil, because yes, it will work without using oil, but it doesn't magnify any more than the 40x lens if you don't use oil. And the 40x lens is better to use without oil than the 100x lens without oil, because the 40x lens has a bigger, wider field of view and a greater depth of field than the 100x lens. So if you're using the 100x lens, you use oil. What you do is when you're rotating the, what can I use here to, I'll use this cup. When you're rotating the objective lens into place to get the next higher power objective lens there. For the 40x lens, what you do is you move it so it's halfway out of place, but the 100x lens is not in place, it's halfway in place. So you have it halfway in between, and then you get your oil and you put on a single drop of oil onto the lens. So we'll use the pen here and put a single drop of oil onto the lens. And then you move the 100x lens so that the lens gets in the drop of oil, and it'll be so close to the specimen, my hand will be the drop of oil, that the lens will come in that drop of oil. Okay, it won't touch the glass slide, but it will be in the drop of oil. And that makes oil from the specimen on the slide to oil on the glass of the 100x objective lens. Any question about any of that? Why oil is working is oil has the same refractive index as glass. And so that allows no light to refract. We'll talk about that later in the lecture. So no light will be lost by refraction. All of the light coming through the specimen will go into the objective lens. So all of the light will be captured by the objective lens, and that will lead to greater resolution and clarity of the image, just because you're getting more light. If you don't use the oil will refract at the glass slide, and some of that will refract away from the lens. And then when the light hits the glass of the lens, a refraction of light will also occur there. Okay, so using oil essentially makes no refraction, because what you're doing is you're essentially making the glass of the slide connect to the glass of the lens. It's not glass in between, it's actually oil, but it's working the same as if it was all glass. And then because the oil has the same refractive index, none of the light will refract. Light refracts whenever it changes from one media to another. So it'll change between glass and air, and then between air and the glass of the lens. Any question about any of that? All right. Whenever you're using oil, you have to remove the oil from the objective lens. And you should remove it, obviously, from the 100x lens, because it's going to be put in the oil. And you should also check the 40x lens, because if you, let me go back to a picture of the microscope. If you put oil on the slide and then you move the objective lenses around, the 40x lens can go through the oil and pick up the oil. So you should check both the 100x lens, which you will have to remove the oil from there. And then you should check the 40x lens to make sure it doesn't have oil on it. Any question about any of that? Where were we? So whenever you're using oil, you have to remove the oil from the microscope. And you should remove it from the slide also. You do not remove the oil from the slide, or not the slide, the ocular lens with anything but lens paper. Regular paper, including Kim wipes, paper towels, any other paper, has wood fibers in it. Wood fibers can scratch the lenses, and the lenses are the most expensive part of the microscope. So we use lens paper, which is paper, but it somehow is treated to remove the wood fiber from the paper. So lens paper does not scratch the lenses, and generally students only clean the lenses with lens paper. Rarely, if a student has a stubborn stain, they will report it to me, the instructor, and I will use a cleaning fluid to remove the stubborn stain. But generally, students don't use the cleaning fluid. They just use lens paper. Okay, any questions about any of that? All right. So the activities, for activity 1, the students in the lab, going into the lab, have to measure the size of the field of view, but you online students can't do that. So the table has already been filled in for you. However, you are expected to know the information in the table and how to use this information to answer the questions below. And essentially what you're doing is you're using this table to get an estimate of the size of the specimen under the microscope. Oops, let's go down and view the table. So for the 4X lens, the diameter is 4.5 millimeters, and the micrometers is just 1,000 times that, 4,500 micrometers. So if a specimen takes up the entire field of view of the 4X lens, you know that the specimen is 4.5 millimeters in size. And then if the specimen takes up about 1/10 the size of the field of view of the 4X lens, then the specimen would be 1/10 this number, or 0.45 millimeters. Any question about how you're estimating the size of a specimen under the microscope? All right, the 10X objective lens has a field of view of 1.8 millimeters. The 40X objective lens has a field of view of 0.045 millimeters. If you don't know, the millimeter is the smallest unit of measure on our ruler, and it's the metric side. Most rulers are both metric and English. I'm trying to find a ruler. Usually I have one here, but I'm not finding one. So let me just go here. I don't know if you can see that, but a millimeter is about the size of one of these letters here, from top to bottom. All right, any questions about this table? All right. You don't really need to know this table, it's to get the diameter, the field of view you're looking at, depending on what objective lens you're using, and the diameter of the field of view times the 4x objective lens times the magnification of the objective lens, what objective lens you're using, divide by the magnification of the objective. But it is important to estimate the size of the specimens you're observing, and all you need to do that is use this table. For example, if the estimate is 1/2 the field of view of the 10x objective lens, then you know that the estimate of the size of the specimen is 0.9 millimeters, because it's half the field of view. All right, so you online students, you will be using a virtual exercise using a microscope virtually in this laboratory exercise. And then you have some questions to answer, not in this document, but in the worksheet for this lab. And we expect you to know and understand the material in this exercise. So in activity 2, you're going to be observing a prepared slide and going through how you do that. Go ahead and read through that. I've kind of already talked about it. Activity 3, you're making a wet mount. For the online students, you're not going to perform this activity. You're not going to be tested on it. If you want to know about it, go ahead and read it. And then know the terms of this lab. And then do your laboratory exercise. We've got some videos for you to watch on general microscope focusing, and then using oil on the microscope, or using oil on the 100x objective. Okay, any questions about any of that? Let me go ahead and switch to the worksheet now. Oh, that's the wrong one. There it is. And then you can click this link for practicing your microscopy skills. You're going to be using a virtual microscope. Let me go ahead and open that. And that's because this page sometimes takes a little while to open. It's a fairly complex program, and so see, it's taking a little while to download. It still hasn't finished, so let's give it a little bit. Oh, there it goes. Now it's finished. All right. You use these links here to get started. The part we want you to do is the explore. So click on explore and then practice with the microscope. Now we don't have a slide here, so the first thing you want to do is get a slide, and you click the box that's the microscope slide box holding slides. And I will do a plant slide, onion root. And so now we're loading it with the slide. And as you can see, initially, we aren't seeing the specimen because it's very blurry. I can just barely see there's part of the onion root. And we want to go to the 4x lens, which is what it defaults to, so it's fine. You might adjust the light. We'll just leave that for the moment. I'm going to coarse focus. So you coarse focus like this and get it into as good a focus as you can get. Probably someplace around here. And then fine focus. All right. And then move it to the center of your field of view And it depends what you're looking at. We'll just look here, in which case it's in the center of the view. We can go to the 10x lens and see how it rotated that. And there it is in focus. Now, from now on, you should only use the fine focus. So let's focus a little bit better on maybe that cell. I'm trying to look for one, maybe that one there. I'll move that to the center of the field of view. I want to focus here because that's looking like it's chromosomes. Let's fine focus someplace around here and go up to the next higher power lens. Right here, I think, is what I was focusing on. So you can see chromosomes right there. This cell is going through probably mitosis. You might fine focus, although that looks pretty good. And then go to the 100x lens. When you go to the 100x lens, you got to add the oil immersion, oil, and that's right here. And did that add the oil? I thought we had to touch up there with the oil. And then fine focus a little further. We're not really where I was looking. I'm gonna have to go down because I'm not seeing what I was focusing on. Whoops, what happened? All right, let me go back. I was supposed to go back and it didn't let me go back. Oh, there it is. I'm totally focusing on that. Why isn't that in the center? There's the drop of oil. Something's wrong with this virtual lab. It's not in the center of the 40x lens. Oh, there it is. That's off from the center though. I can't even get it centered now. And then fine focus on that. That's pretty close. Maybe about right there. We can adjust the light. All right, any questions on how you use this microscope? Remove the slide. You got to use lens paper to remove the, this is the lens paper. Remove the oil from the objective lens, and you're putting the slide in the slide box. And that rotated to the 4x lens, which is what you should do when you're done. Move the 4x lens into place and then put away the microscope. All right, any questions about the virtual lab? If not, I'm going to close it. For this part, you can practice naming the parts of the microscope. And this is actually a game. See if I can remember how to use this. Nope, not there. You don't want to do that because that'll download something. Maybe it's already ready to go. Just press play. You want to see the play button? Oh, it's right here. And then we go 9, you go here for what 9 is. Oh, body tube, sorry. There's the question there. The body tube is here. That told me I got it wrong. What's wrong here? Well, that's the foot, the stage foot, so that's not it either. I'm not sure. Oh, they were talking that as the body tube. I was thinking they were talking about the body tube of the microscope. They're talking about the body tube of the ocular lens. The fine adjustment knob is the little one, which would be here. The power switch. I'm not seeing it. Let me scroll down a little. Oh, here it is. The stage. So it gives you a funny sound if it's correct, and the color will be green. If So the one that's wrong was the yellow one. Let's take the next one wrong. The diaphragm is right there, and I'm going to go here. And now let's do the iris diaphragm. Yeah, I got that one wrong, so it's a different color than blue or green. Revolving nose piece right there. So if everything's correct, it's green. I think when you're all done, it'll tell you how many you got right and how many were wrong. How'd we do? Well, I got 15 points. And then you can go there for your next game. All right, that's how you do this, just to practice on using the microscope. I think I'm going to close this. And then answer the questions. There's a number of questions under 4. A, when focusing a specimen, you should always start with what objective lens. 5, when using low power, high power, and oil objectives, only what focus adjustment job should be used, and it's either a fine or coarse. The type of microscope used in the lab is, and it's 2 names here. Okay. Do not say an electron microscope because that's not correct. Don't say a simple microscope because that's not correct. So say what's correct. All right, so answer the questions and then move down to question 2. Suppose a typical bacterial cell is 2 micrometers in diameter. In the circle below, which represents the field of view under the microscope when you're looking at it, state how many cells can fit across the field of view using the oil immersion lens. So if a cell is 2 micrometers, how many of them can fit across the field of view of the 100x objective lens? And that's your last question. When you're finished, submit your answers. I will be here until 8 o'clock to answer questions or until the last student logs out. When the last student logs out, I will log out as well. So get started on the lab. And remember, if you did not get lab 0 or lab 01 at 100%, you can make corrections by this Saturday to still get 100%. And let me remind you, if I have a 0.01 on your lab score, that is not your grade for that lab. That is a key to tell me to go back to that lab and see if you have made an update with corrections. And then I'll regrade the lab. All right, get started. I'm going to stop the share and stop recording. All right, I was asked a question about number 2 on the worksheet, and I asked the student what lens they were using, and they said the oil immersion lens. Okay, so what's the field of view, the diameter of the field of view for the oil immersion lens?
180 micrometers.
Okay, that sounds right. Let me go to that module and the table just to make sure. Oh, wrong table. That's correct. All right, so in this table, can you see this screen?
No.
All right, let me share the screen. All right, so this is the field of view, which represents 180 micrometers. How many cells can you put across 180 micrometers. Okay. Are you there?
Yeah.
All right. Are you having trouble or what?
Well,